I'm just waiting that you people all join together so that we can proceed with the talk. Okay, Kirti has joined. Vishal has joined. So we are going to start with the second lecture, and which is, of course, I'm going live, and the lecture is on processes and functions in GIS. In the last lecture, we have discussed about the GIS definition. What are the different components of GIS? As of now, you are aware that when we are talking about the GIS, we are talking basically about the planning tool or the decision makers tool. So in the last class, when we were discussing about the components, we have discussed about the hardware, software, we have discussed about the data, we have discussed about the people, and then we have discussed about the methods, right? So by now we are aware about that the GIS deals with a lot of data which is available to us in better analyzing and making the decisions based on the inputs which are available to us. And today we will be talking about that what are the different processes and functions in the GIS. So as you know, when we talk about the GIS, we have to understand that how it works. So when I talk about the GIS stores information about the globe as a collection of various thematic layers that can be linked together by geography. So as we know that when we are talking about any thematic layer, we are talking about the spatial distribution of a particular theme. And we want to know that how much is the area under a particular type of the land use, and at how many places the particular type of land use is. And when we associate this with different type of the layers, like what is the type of the soil, what is the groundwater availability, what is the quality of groundwater in that particular area, then we can understand that what are the constraints which are there in association with the types of the soil, which are commanding or directing the present land use. So in other words, we can say that this simple but extremely powerful and versatile concept has proven to be invaluable for solving many problems, from local specific natural resource management plans, local specific services, tracking of vehicles, monitoring of planning applications, to modeling global phenomena. एक मैं सिंपल सी बात करूं कि अगर आप एक यंग एंटरप्रेन्योर हैं, आपके पास में 200 व्हीकल्स का एक फ्लीट है और उन फ्लीट को आप हरियाणा और एनसीआर रीजन में रन करते हैं. अगर आपने देखा कि कुछ जो ड्राइवर्स हैं वो जो किलोमीटर्स हैं उसका जो एग्जैक्ट आपको नहीं बता रहे हैं कि भाई कितना किलोमीटर्स हुआ है, तो जैसे यहाँ से दिल्ली हम एयरपोर्ट की बात करते हैं तो इट्स अराउंड 200 किलोमीटर्स, एंड द ड्राइवर सेज दैट अप एंड डाउन इट इज़ 500 किलोमीटर्स. सो नाउ यू वांट टू नो दैट हाउ दिस प्लेफरेज इज़ टेकिंग प्लेस. तो उसके लिए आपने क्या किया कि हरियाणा का और एनसीआर रीजन का पूरा जो रोड ट्रांसपोर्ट मैप है उसको आपने डिजिटाइज किया, डिजिटाइज करके आपने अपने कंप्यूटर के ऊपर डाल दिया, एंड यू हैव फिटेड ऑल योर व्हीकल्स विद द GPS, राइट? सो यू हैव असाइंड a task to a particular driver. He is going to the airport, and when he is coming back, he has taken taken a diversion, say from Gannor to about 25 kilometers, and again he has taken a diversion from Karnal to 25 kilometers, right? When he came, then he said that, sir, it is 500 kilometers, and you asked him that, do you know that when you reached Gannor, you have taken a diversion for about 25 kilometers, and then he will be able to know that, oh, that means there is some tracking going on, right? So what I mean is that you can have the exact tracking of the vehicles, and by that way you can minimize the pilferage. In other words, whatever we are seeing nowadays, we are talking about the metro trains, or we are talking about the other vehicles which are having the GPS fitted, so we can know the exact location of these vehicles. So tracking of the vehicles becomes easy. Location specific services becomes easy. You might have heard about the Corona Kavach. It's a small application which is going to be developed by the J.C. Bose University of Science and Technology, Faridabad. So what they are doing, they are using a terminology geofencing, and by using the geofencing, if there is any corona patient and he is having the location on, then when you are having this location app opened in your mobile phone, then whenever you are coming near to a particular radius, then you will be getting a beep, and you will be understanding that there is some corona patient which is nearby, so you can save yourself. So these type of services are versatile use of the GPS in association with the geographical information system. So when we talk about the GIS, we say that there are four major processes in GIS. So when we talk about the input, then we are talking about the measurements, right? So the first process is measurement, second is mapping, third is monitoring, and fourth is modeling. So when I talk about the measurement, as you know that when we're talking about the satellite data, then reflectance and the reflectivity is the parameter which we are measuring, and the similar looking features which are giving almost the similar reflectance values, we are putting these together. So putting these together is nothing but it's the process of mapping, right? So we know that there are certain things which are common in nature, and then we are putting these into one class, so that is our mapping. When we do the mapping over a period of time, then we call it as the monitoring. We want to see the changes in a particular class, and then we are studying in a temporal way. For example, we have the data of 1980, 1990, 2000, 2010, then 2020, right? So we want to see that how these things are behaving. So we are going to see the changes with respect to time, so that is monitoring. Why we want to see the changes? The basic idea behind it, that if we are having the data of say land use, hydrology or vegetation for last about 25 to 30 years, so we have studied that what is the rate of change in a particular feature. So then we can project for the future that by 2030 or 2050 how a particular area is going to behave. Or if we take an example of Kurukshetra city, and we are having the data of last say 30 years, so we have taken that satellite data and we have observed that how the city is growing. So after understanding that phenomena, at what rate the city is growing, then you can project for the future by 2030 how much area will be required for the expansion of the city. Not only this is a simple example. Then we can understand that how much inhabitants are going to be increased, and what will be the requirement of the utility services. For example, we are talking about electricity, we are talking about water, all these requirements we will be able to manage. So this is the process. In other words, we can say that measurement is nothing but it represents the acquisition of the data, and it may be related to natural resources, land holdings, pollutants, record of traffic flow, etc. And mapping, as we have discussed, that we are talking about putting the similar things together, or we are trying to acquire the data to yield some intelligible information, right? In other words, we say that this is the spatial data which involves the representation of the measurement in the spatial context, that how it is distributed over the surface of the earth. And then monitoring, as we have seen, that we are trying to manage it over a period of time. In modeling, we are doing the futuristic predictions, that how it is going to behave in the time to come. So when we talk about all these things, we can take any of the thematic layer, for example, land use, land cover, and we are interested that land use, land cover, there is a particular class which is wasteland, a land which is lying waste from last 5 years, right? So we want to see that how it has behaved in last 30 years. Then we are trying to project it for the future, that by 2030, that what will be the rate of conversion from the wasteland to say urban areas or the agricultural land. So these type of things we can understand. And another very important, say groundwater depth or prospects. So if we are studying the groundwater depth over a period of time, and we see that there is a rate of decline, decennial decline or the per year decline, then we can project for the future if the similar cropping pattern is there and similar rainfall conditions are there, so the consumption pattern will also be the same. So we can project for the future by 2030 or 2040 what will be the scenario as far as the groundwater decline is concerned. The next is the data types. So when we talk about the data types in the GIS, we say that data in GIS is of two types. One is the vector data, another is the raster data. So when we talk about the vector data, we say if the data is represented in the form of point, line or polygon, or these are the discrete features. So these we call it as the vector data. So if we are having any map in which all the features are represented in this form, then that we say that it is the vector map. So if we are having the points, we can say that if there are some events which has happened or there are say well locations, so these are represented by the points. And networks, if we are having the road, we are having the railway line, we are having canal, we are having telephone line, we are having electricity lines, so these are represented by the lines. And if we are having a class in the form of the polygon, for example the water body, urban areas, so these are represented by the polygons. Vector GIS is useful for the analysis, display and retrieval and management of the above type of the data, that means the vector type of the data. And the second important, another important data type is the raster data. So raster data, in this we deal with the square cells. As we have discussed in the remote sensing image, that when we go on enlarging a particular image, then in the end we are left with a square grid. So this is nothing but it is a pixel. So a square grid, if the data is represented in the form of square grid, then we say that it is the raster data. The ready example is the digital image of the satellites which we are receiving. Raster data, GIS is better suited for representing and processing continuous varying features. So if we are having the continuous varying features, or we are having, we are having the features which are present on the surface of the earth, and we are recording it in the form of the pixels, and these are arranged in the row and column fashion, then we call it as a satellite scene. And best example of application type is the site suitability analysis, which I have also discussed in the first lecture, that when we are talking about the solid waste management. So it is the data is represented in this slide. We have discussed in the previous class also that if we are having the data measured in XY, that is point, line or polygon, then we say it is the spatial data. If it is the grid, then we say it is the raster data, right? Point, line, polygon is the vector data. So these features may have certain characteristics. So those characteristics may be represented in the form of non-locational, or we call it also as the tabular data. And as we know that whatever data is there may be a dynamic component into it, in the sense that if you're talking about the land use, land cover classes, these may change over a period of time, right? So it is also very, very important that data is always having a temporal dimension, that it may change with the passage of time. The similar has been represented if you see the left hand side top figure. So if you are having the data which is in the form of like 4 is the point, we are having 3 is the line, and 2 and 1 are the polygons, right? So in the left hand side it is the vector data, and on the right hand side you are seeing the grid, so it is the raster data. And then we can see the values, that what are the values of different features at different places. So from the processes we move to the task. What are the tasks which we can perform in the GIS? So in the GIS we can perform a number of tasks which takes us right from the input to the visualization or the output, right? So when we're talking about the input is nothing that whatever data is available to us in the hard copy that we would like to input into the computer. So inputting for the computer, as we know that we can have the two type of the input devices. One can be the digitizer or the scanner, and one can be the digitizer, another can be the scanner, right? So in the digitizer we are having an electronic table which is connected to the desktop or the laptop, and we are displaying the map into it, we are pasting it. We are having the different features which are present over there, and then we are, if this is a point feature, feature, we are digitizing in the point mode. If it is the line feature, then we are digitizing in the line mode. And then later on we are going for the topology building, so different lines may merge together, and we are also digitizing the polygons, right? So in the input we are talking about this. And then manipulation, manipulation is nothing, we are having a data on a particular scale, right? So if we want to change the scale, we want to georeference it, provide the same latitude and longitude information which is available to us, so that we are, through topo sheets or otherwise, we want to put it, or there may be certain errors which has taken place, so we want to edit it, right? So all these type of thing we do in the manipulation, or you can say the change in the correcting it. And then another can be the buffer creation. We are having a particular point, right? It is a factory, right? So we want to understand the pollution influence in the surrounding areas. So we want to create a 1 kilometer buffer around it, a circular buffer around the point. Or if we are having a line, say national highway, right? So we want to understand that what is the effect of the national highway on the surrounding areas land use, land cover, right? So we are taking a 500 meter, 1 kilometer buffer on the either side. So we want to study the influence of a particular thing. And then management. If we have to import the data, we have to export the data, we want to convert the data into different formats, or we want to back up the data, or we want to recover the data. All these things will come under the management. And then after we have got the data input into the computer, I will be discussing again next slide little bit into the detail. So when we have input all the data into the computer, then why we have input the data, what for? So for that purpose we want to understand very simple queries, that what lies here or where lies this. We are having a map, just put our cursor, and by putting the cursor we will be able to see that what this particular feature is of type. And another, we can do the complex queries, say number of parameters are there, we have taken those different classes from different parameters, given those parameters to the GIS, and then we want to know which is the area which gives or meets all these different queries. And another very important application of the query and analysis can be that we want to understand, we want to see that what is the line of sight or what is the visibility analysis. So if we are aligning the highways, we are talking about the alignment of the new roads, so then we want to see that what is the line of sight, right? So it helps the right visibility when the people are traveling. So these type of that speed limits or other things are decided by this application. And then the last is the visualization. That is, we have got the map, we have prepared a number of derivative maps by integrating these maps. So these final maps can be either in the form of a colored map, a black and white map, a particular class map, or we can have the 3D models or fly through. So we are having a location from A to B, so we want to see that what will be the terrain from A to B, or we can represent the output in the form of the graph. So these are the visualization, that is the output from the GIS. Or to see these in a little bit more succinct manner, I will just show you in this slide. When I'm talking about the GIS functions, the first is, when we're talking about input, it's a data acquisition and pre-processing. So in the data acquisition, whatever data is available to us in the hard copy, that may be either scanned or that may be put onto the digitizing table. And the basic idea is that we want to input all the features which are available in this map into the computer in the soft way. So once we will be doing the georeferencing, entering the four corner coordinates, so that we are defining that this is the area under which we are going to digitize, we are put all those features together, right? So once you are having the different features in a map, for example, we are having the well locations, so we will be digitizing in the point mode. We have selected a point and we are going to each and every location and we are clicking there with the mouse. So we will be transferring those into the computer, and then later on we can give a number of parameters which we were discussing about the attribute or the associated data, that who is the owner of the well, what is the application of the well, whether it is for the drinking purpose, it is for the irrigation purpose, or it is for some other purpose. So these type of associated parameters, what is the depth, what is the parapet, how much is the distance from a particular village or area, all these type of parameters we can associate with that point. Those we call it as the attribute or the associated parameters. So when we are having road or we are having a canal, so then we can go in the line mode from one point to the other point, right? So joining together. So then we later on we can say that what this line indicates, whether it is a canal, it is a road, or anything else. And then there may be a, when we are going ahead with the digitization, there may be my hand has sagged or some other thing has happened. So there may be some error. My cursor has moved, right? So I want to remove all these errors. So error removal, we call it as the editing, right? So once we have done the editing, then we can go for the topology building. So there are the line features which will be converted into the polygons. Then we have to understand that what should be the projection. So we can do the projection transformation, or we can also go for the format conversion. And attribute assignments, I have already discussed that it may be a line, it may be a point. So what are the different characteristics of these points or the lines? Those we are attaching with the features. So then database management and retrieval. The basic idea is that once we have created all these maps, so one map we call it as a layer, right? So we have put a number of layers into the GIS so that we can go for the different type of the analysis. Though analysis may be the attribute query, or that may be the object oriented databases, right? So these are the basic idea that how different database which we have stored into the computer, how we are going to analyze that. So once the database has been created, right, so then we will be the basic idea is we would like to analyze that if there is a land use, so how much is the wasteland in a particular area, or how much area is under the water bodies. We want to understand that what can be the recharge in a particular area, right? So that is basically we want to understand the extent of the water bodies in that particular area, right? So if we want to go for the measurements, we want to understand the buffer, the influence zone, or we want to understand, we are having two maps, so we want to go for overlay. We want to see that if the soil type is a sandy loam, so what is the land use in that soil loam areas, right? Or connectivity operations. So we are having point A and point B, if there is any connectivity between these 2 points. So these we basically do under spatial measurement and analysis. And then the next or the last, we can say that it is the graphic output and the visualization. So when we are talking about the graphic output and visualization, when we are having a number of maps which are available to us, so all these maps we are putting into the computer, and then we are trying to see that when we are talking about the soil type is the next or the last, we can say. So when we are trying to understand, I was just checking that if there are some questions which has come up, but I'm only seeing the good morning and good afternoon. That's good. If you have any questions, you can just put into the live chat. So when I'm talking about the last, you can say function of the GIS, that is basically that we are having the output in the form of either the graph or in the form of the maps, right? So in the output, on what scale we require the output, right? There may be a small land use classes which are available over there. So I want to just remove these small classes, because we cannot do any natural resource planning in these areas, right? So that is under generalization. And then the topographic and the statistical maps. So whatever maps we are having, so what is the topography of different features which are present in the map, if you want to see, or we want to have the 3D visualization. So all these things, that what should be the output of the data we want to see. So that is basically your visualization, right? So I think today my basic purpose was that I want to discuss with you a number of features which are going to help us for understanding the functions and the processes in the GIS, right? So I think this is the last slide which I want to discuss with you. And if you have any questions, please feel free, either send me those questions on the WhatsApp. We can discuss these in the next session, or we are having a WhatsApp group. You can raise your queries there as well. So thank you very much, dear students, for presenting here.